Hello, physics students, and welcome to our next unit. This unit is on waves, and it's going to cover waves in general, sound waves, and then light waves. We're going to talk about light waves and electromagnetic waves after IA3, and so the next 2 weeks you'll spend just talking about waves and talking about sound. And the two main kind of waves we're going to look at are going to be transverse and pressure waves. These are also called longitudinal waves. We're going to call those pressure longitudinal waves. And then these are transverse. And the pressure longitudinal wave you know best is called sound. And that's because as the sound is made through a vibration, it pushes the air forwards and backwards, and it travels out. So, in a longitudinal wave or a pressure wave, the matter vibrates back and forth the same direction as the energy travels. In a transverse wave, where it's going up and down, it's perpendicular. So the energy is transferred one way and the matter moves at right angles up and down compared to it. All right, so talking about sound, I have my daughter's automaton to talk about sound today, and this is really cool. You push along this little black bar and it makes different sounds. And there's a few things we can measure about all waves, and I thought I would just use the automaton to explain them. Like you have frequency. Frequency for a sound wave is called pitch, and so that would be a higher frequency and that would be a lower frequency. And when you change the frequency, you also change something else about the wave. Does anyone remember what else you change when you change the frequency? And if you said wavelength, then you are correct. So here's two examples. Which wave do you think has a larger frequency? And just think about frequency as like how often something occurs, how frequently you brush your teeth or eat. And so if you said that the top one had a greater frequency, you are correct. Now, just looking at this, which one do you think has a greater wavelength? Wavelength is of just what it says it is. It is the length of the wave. And if you said that the bottom one had a greater wavelength, it certainly did. The top one is much shorter. And so we can see that if you have a higher frequency, you have a smaller wavelength. And so those are inversely related. And there is one more property that's important. Well, there's more than one more, but one more I'll talk about, and that is the energy of a wave. So the energy of the wave is given by the amplitude. By the way, these two waves have the same amplitude. Just like my two notes have the same loudness. For sound, loudness is the energy. And I can make these sound louder by opening the automaton's mouth. So less energy, more energy. Higher sound, taller sound is more energy. Shorter sound is less energy. We can also adjust the velocity is important, and we'll talk more about that in Live Class Connect, and you can check it out right here in the OHS. Thank you and enjoy the waves unit. I will see you later.